Okay, good morning everyone, and welcome to Meet Your Future Careers in Science Week. I'm Bronwyn and I'm part of the team at Greater Manchester Combined Authority. And in 2019, we launched Meet Your Future so that young people just like you can have meaningful conversations with employers, find out about the workplace and take part in different projects that are linked to the world of work too. And over the past 12 months or so, young people from 10 boroughs across Greater Manchester, we've been talking to you, finding out about how you are feeling, how you think that you should be supported now and also within the future. And we've been listening a lot and we've learned so much. So from this, we have developed a suite of information, resources and services that are really there to help you. And you can find these on our Greater Manchester Apprenticeship and Careers Service, GMAX. I'll pop the link into the chat as well. And from all of this, we have also adapted Meet Your Future to fit in better with what you've been telling us. And through this year, you can join sessions with Greater Manchester and national employers and really find out about our growth sectors across Greater Manchester, the different pathways that you could take as well, and the vast array of opportunities. And today you'll hear from all about science in the NHS. So you'll hear from Chloe and you're also going to hear from some of our NHS ambassadors as well about how they use science in their day-to-day roles. And hopefully today's session will inform you and inspire you and show you how you should be hopeful and optimistic about your future here in Greater Manchester. And we've also got a question box too, so please ask any questions throughout the session, and there'll be lots of time for you to ask these questions to the ambassadors and really find out about what it is like working in the NHS, doing a job that's linked to science. So I'm now going to pass over to Chloe.
Thank you. Let me just share my screen. Can we see the screen?
Yes.
Fabulous. Okay, so any questions kind of people have throughout, I can't see the chat box right now, but I'll be able to kind of get my colleagues to help you be able to ask those. This is the Science in the NHS session. So my name's Chloe. I'm a coordinator at the Greater Manchester Health and Social Care Careers Hub, and our job is to tell you all about careers within the NHS and how you can access those careers. And with it being British Science Week, we're looking particularly at science in the NHS for this session. And as you just heard, you're going to hear a bit from me, but you're mainly going to hear from the actual scientists within the NHS. So you can find out about how they got to where they are, how they use science in their everyday roles. And this is your chance to ask them any questions you want. So please make use of the chat box and being able to ask questions. This is a really good opportunity to ask any of those questions you have and think about whether this is a really good career option for you. So my first question to you, when we're thinking about the NHS and we're thinking about how science is used within the NHS, I wanted to ask you how many roles you believe there were in the NHS altogether. So I'll give you a minute just to start popping into the chat how many roles you believe there are within the NHS. So is it A, 350, B, 275, or C, 425? So I'll give you a minute to pop any answers in the chat for me. There's a slight delay from when I say things and when you hear them, so that's the reason for this pause.
Chloe, I don't know if you can see that, but one group has said 425. Oh, another group has said 425 as well.
Okay, so we had a few guesses here. So the answer is 350. So actually you did a really good job because it's slightly over 350 and there's kind of more and more roles evolving all of the time, and people tend to say a bit lower than that. I think people normally don't think of the very varied amount of roles that you can do within the NHS. So I just wanted to put on the screen here, this session is particularly about science within the NHS, but I wanted to put on the screen some of the varied roles that you can do within the NHS, so you could have a quick look and see if any of those are of interest to you. As you can see in the middle of the screen there, we have the healthcare science, and that obviously uses science within the NHS, and that's a big portion of the NHS. But I wanted you to look at the other roles as well, because as you can imagine, there's lots of roles that if they're not directly linked to science, they involve some kind of science within the NHS. So you've got things like the allied health professions. They're really specific roles within the NHS that people do, and these people kind of treat, rehabilitate patients, and there's lots of varied allied health roles that you can do. We'll hear more about healthcare science a bit later. We've got nursing and midwifery, and you've got different types of nurses and they have different kind of skill sets, and you've got your midwives and midwifery assistants as well, and again kind of definitely a science kind of underpinning to these roles. Health and social care, so you have the people that are working more directly with those that they're caring for, and you also have corporate staff, so the non-clinical side of the NHS, and they're kind of using technology within their role, so administration, recruitment, finance. You've also got estates and facilities, so things like engineers who definitely use science within their roles, and then you've also got other services that people provide to the hospital, so catering, linen and caretaker. So I wanted just to do a quick overview so that you can think about those 350 roles. They're obviously not all on the screen now, but it gives you a bit of an indication of how varied the NHS is. And today we'll be looking specifically at those science roles. So my next question for you is, if you were to join the NHS in the future, which if you were to join the NHS in the future, I was about to word that a bit weirdly then. The NHS workforce is the largest in the world. So how many, thinking about the number of people within the NHS, does that make it the second largest workforce in the world, the 5th largest workforce in the world, or the 10th largest workforce in the world? So again, I can't see the chat, but I'll just wait until people start putting any of their responses in for me.
So we've had one, oh, we're getting a bit of a mix, Chloe. So we've got a couple of A's and a couple of B's.
Fabulous. Well, I can let you know that the NHS is actually the 5th largest workforce in the whole world. And if you think about how impressive that is, considering the NHS is only on our kind of little island that we live on, in the whole world, it's the 5th largest workforce. So organisations that beat the NHS would be McDonald's, that's one of them, and also the Chinese Army is one of them as well. So the NHS isn't doing too badly to be the 5th largest in the world. So I kind of wanted to show you the roles and the size of the NHS so you could think about the organisation as a whole when you hear from our ambassador today. And I think it's quite exciting to think about the prospect of being part of such a large organisation that does so many different things. And I wanted to kind of get that across to you today so you can keep that in mind when you're asking your questions and you're hearing from the ambassadors as well. So for your pre-session task, some of you might have completed this. You were asked to research the following careers. So you might not have ever heard of these job titles before, but you were asked to research what these job titles were. And I also want people to start putting into the chat now which sciences you think might be used within these professions. So we've got a diagnostic radiography, and anyone in this kind of role would use technology to take images of the inside of patients, and it helps understand and diagnose conditions. So you might have had experience of this kind of job role happening to you or a family member before. So that's what diagnostic radiography is. There's also therapeutic radiography, so slightly different. People in these roles help those who are dealing with cancer, and they work with patients and colleagues to design treatment programs, and they support that patient right up until when their treatment ends. So a really, really important role. And we also have a prosthetist and an orthotist. So prosthetists create and fit artificial replacements for patients who are missing limbs. And orthotists correct problems to do with nerves, muscles and bones, and they use kind of a wide range of things to be able to do this. So I wanted to ask you, now knowing about these careers, what sort of sciences do we think are really important for these professions? Again, I can't see the chat, so I'll just wait until any kind of responses come in about this.
We're still waiting for responses, Chloe, so please do, if you've got any ideas, please pop them in the chat. But I mean, for myself, I didn't know about some of these different roles. Definitely think biology fits in there a bit.
Definitely.
Oh, we've just had a response from Lost Star, because they've said, oh, so biology, chemistry and physics.
Yeah, and that is correct. So in terms of the, is this going to work? Here we go. In terms of the sciences used in these professions, so you're right, biology, chemistry and physics, really important. And I think when people think of science within the NHS, because you're working with people and their bodies, people think instantly of biology. I think that's a common one, and that's very true. Lots of sciences use biology. But if you're more interested in chemistry and physics, or perhaps actually you've got a real interest in maths or engineering, there's certainly roles for you within the NHS following these careers. And we're going to hear from our ambassadors today who have different kind of science interests and how they got into their roles. So definitely keep that in mind. So all of the sciences on the screen would be used in different professions within the NHS. So there's definitely something for everyone, depending on where your interests are. And in terms of what all these roles have in common, they're all kind of sit under this category, which is healthcare science, which I said we would come back to today. So healthcare science is a category that we kind of put the science area of the NHS within. There are over 50,000 healthcare scientists within the NHS. Their work contributes to 80% of all diagnoses within the NHS. So imagine without them, the NHS would really struggle. They do a really important role of diagnosing people. There are more than 50 specialisms, so there's a whole range. We won't be able to even hear about them all today, but if you wanted to do further research, there's a whole range of kind of science careers you can go into within the NHS. But they're typically split up into 4 areas. So you have laboratory sciences, so hematology and microbiology. You have physiological sciences, so things like vascular science, audiology, medical physics and clinical engineering. So this is where your physics kind of interests sit. So radiotherapy physics, nuclear medicine. And then bioinformatics. So that might be more of interest for people who are into computer science, IT, that sits within this bioinformatics category. So I wanted to give you the opportunity now for the rest of the session to kind of hear from our ambassadors and do a Q&A, because it's really a really interesting way to learn about different roles by hearing from the people themselves who are the experts. So I'm going to introduce you to our ambassadors. You'll hear them talk for about 5 minutes about their roles, each of them. And as they're talking, if there are any questions, please pop them in the chat, and then we'll be able to tailor the session to basically whatever you are interested in knowing. So any questions you have, either for all of the ambassadors, or if you hear something that one of them says that you're really interested in, please don't hesitate to pop questions in the chat, and then we'll be able to kind of do a Q&A throughout the rest of the session, and hopefully you'll learn lots more about science roles. So I'm going to just stop sharing my screen now so you can see our scientists. So I'm just going to pass over to Jodie first, because that's who's at the top of my screen. So Jodie will be able to introduce herself and tell you a bit more about her role and how she got there.
Hello, hi, can everyone hear me okay? Okay, so yeah, I'm Jodie. I am a final year trainee clinical scientist, and I work in radiotherapy physics at the Christie Hospital in Manchester. So kind of like my day-to-day role, so I've been working in my specialism in radiotherapy for the last 2 years of my training, and radiotherapy is using radiation to treat people with cancer, and we do that. We have like a variety of ways that we can do that. We have physical radioactive sources, but then we also have radiation generators that physics are quite heavily involved in calibrating and measuring their output. We also do a lot of planning for patients who come through our department. So every single patient who comes for radiotherapy has a bespoke treatment plan. So physics are quite heavily involved in that. And yeah, just a bit about how I got into this role as well. So I did my GCSEs I had triple science GCSEs. I know some of you are sort of at that point now of doing GCSEs. And then I did my A-levels in physics, maths, chemistry and German, and then went on to do physics with medical physics at the University of Nottingham. And it was when I was in my final year of uni, one of my medical physics lecturers kind of let me know about the scientist training programme in the NHS. So that's a 3-year training programme, which I'm in my last year of now. So I thought I'd give that a try, try and apply for that, and you know, had like lots of support from my uni. Like, so I had we had quite a active medical physics department in my university. So yeah, I had some lots of support, lots of prep for that interview, and yeah, you know, thankfully, luckily, got a place on the science training programme. But even though I have my degree was in physics with medical physics, people come onto the STP from all kinds of backgrounds. You know, we have people who've done like astrophysics, we have people who've done PhDs in aspects of physics that aren't really related to medical physics and then have come to medical physics. So yeah, there's a really diverse diverse range of backgrounds of people that come into this job. So yeah, feel free to ask any questions about my role or how I got into this, or if you think it might be right for you. Yep.
Thank you, Jodie. Whilst questions kind of come through for yourself or any of the ambassadors, I'll move on to allow all the ambassadors to speak, and then any questions people have, please continue to kind of pop them in the chat as you think of them, and we'll be able to go back to ambassadors and ask those questions. But thank you for introducing yourself. I'll move on to Claire now. Claire's has difficulties with the camera, but Claire is here and you can hear Claire. So I'll let Claire introduce herself and talk a bit about your role as well.
Hello, I'm Claire. I'm a pre-registration clinical scientist at the Northwest Genomics Laboratory Hub at Liverpool Women's Hospital. I currently work in the genetics oncology section, and I've just gone into my second year. My day-to-day duties are very varied, but I'm mainly involved in the analysis of G-banded chromosomes from samples of blood or bone marrow, as well as fish and a range of other molecular tests. I take part in a duty scientist role, which involves making decisions on the right processing pathways for samples based on their disease types. And I also compile a range of complex clinical reports. So the oncology section is very busy, and the results from our tests are very important as it provides the information for treatment pathways for patients who are very ill. So how I got into my role was that I knew I enjoyed science during my A-levels, and I particularly enjoyed biology. And there was just something about genetics that really interested me, so I did my degree in genetics. But I had no idea what jobs would be available. And I left uni and I was a bit like, oh, what am I going to do? And I saw an opportunity to volunteer at the laboratory, and I did that. And then I got a job as an associate practitioner in the lab, and that role was a laboratory-based role, and I did the practical work, which involved things like specimen reception and booking samples in. And then I moved on and got a job as a genetic technologist, and I was involved in some more complex laboratory tasks, and also got to be involved with the analysis and interpreting of results. But after working here for a few years, I realised that I wanted to be a scientist, and that job would involve running services in the department, involved in the analysis and reporting of more complex cases, and even the development of new tests. So currently I am training via what is known as the Route 2 pathway, and this is an evidence-based on-the-job route to becoming a scientist, because there's also, as Jodie's doing, you can become a scientist through the scientist training programme. This route takes around 3 years for you to get enough experience to compile a portfolio to demonstrate specific competencies. And once you submit your portfolio and it's been deemed acceptable, you're then invited for a final interview. If you complete this successfully, then you can apply to be a registered clinical scientist. So I'd just say the best thing about my job is I'm always learning something new, and we're always implementing new tests into the laboratory which could help in the diagnosis or treatment of patients. And I also enjoy that we're involved in lots of exciting research projects, including something you may have heard of, the 100,000 Genomes Project. So if you have any questions, I'd be happy to answer them.
Thank you, Claire. That was a great summary. So as Claire said, any questions, please pop them in the Q&A function and we'll be able to answer those. And I'll lastly pass on to Chris, who again will be able to introduce himself and talk a bit about his role.
Hi everybody, how's it going? So I'm also a pre-registration clinical scientist at the Northwest.
Oh, sorry, Chris, I think we're struggling to hear you. I can hear you faintly, but not very loud.
Okay, oh, is that a bit better? Can you hear me at all?
That's a bit better, yeah, thank you.
It's a bit closer. Okay, so my name's Chris. I'm also a pre-registration clinical scientist at the Northwest Genomic Laboratory Hub along with Claire. So even though she doesn't have a webcam on, I can let you know she is very lovely. So that's
Oh, thanks.
So Claire talked about how she worked in the genomic side. I work in the rare disease side of the lab. So typically my job will involve doing what's called variant analysis. So within our DNA, within our genome, we will have tiny little variants, which are slightly different between individuals. And my job is to look for any of those variants which are potentially pathogenic, which means do they cause rare diseases. So we have samples that are referred to as from clinicians and doctors for patients with rare diseases or showing symptoms of rare disease. We essentially identify whether there's a genetic background or reason that disease. So in terms of my background, can't even remember what GCSEs I did anymore. But for my A levels, I did biology, chemistry, business and economics, and then did maths at AS level. And the same as Claire, I did genetics at university. And I just found it fascinating that in genetics we have four bases, are kind of the code, the building blocks of our DNA. And just from four different bases, we can create all the complexity of life. And it was basically just that made me decide to do genetics. I just found it fascinating, and I still do. Within my course, I had a year in industry where I went and worked for a forensic DNA company for a year, and they offered me a job after I graduated. So unlike a lot of people within our kind of lab who typically went down more of an academic route that have masters and PhDs, I went and worked in forensic science for 10 years. So by the end, I was a technical team lead for a scene of crime and reference DNA lab. So there's a lot of similarities between forensics and healthcare in the way that we manipulate DNA. So we have the extraction, the quantification, amplification and sequencing. We just essentially look at different parts of the DNA and for different purposes. And I also worked as a technical lead in a COVID lab. So a couple of years ago when that all happened. If you remember that, that's still going on apparently. So that was fascinating. And by setting up that lab, we did a lot of work for NHS patients and staff before the Lighthouse labs were set up when I was working in my forensic lab. So that was a real motivation for me to explore how I could use my genetics and scientific background within healthcare and specifically the NHS. And yeah, I applied for the STP, which Jodie talked about previously. Unfortunately, I didn't get into that, but then found the Route 2 course, which is perfect as I'm now also, having been based in Liverpool for 15 years, the role at the Women's Hospital is just around the corner. So that's kind of my kind of career background and how I got there. I think the lessons that I've learned from the last 10, 15 years or whatever is that if you do something that you enjoy and it's something that you feel motivated to do and something that isn't a chore to kind of go in every morning, that's the most important thing that you can do. So just follow what it is that you feel interested in and the rest will.
Thank you, Chris. That was a really good kind of introduction from all three of you, and it's really interesting to hear just between the three of you the slightly different roles that you do sitting within this area. Whilst questions start to come through, I can see there is one question in the chat for Jodie, which asks, do you check for various cancers within the body within your role?
So in terms of actually diagnosing cancer, that's typically up to consultant doctors at our trust who will diagnose. But there are a lot of medical physicists involved in imaging. So I don't know if people who've had scans themselves or family members have had various types of scans. There are lots of physicists involved in making those images better, and for imaging that involves radiation, improving that imaging modality so that doctors can have images which they can get all their clinical information from with a lower radiation dose. So although we don't diagnose, we are still involved in the sort of diagnostic pathway through imaging. And I'm sure Chris and Claire as well are also involved in diagnostic as well of oncology from their role.
Fabulous, thank you. Just a question kind of from me whilst we wait for any other questions to come through. I would be interested to know, every role in the NHS seems to work as part of a team. You're never really working by yourself. So what other kind of healthcare professionals do you regularly work with kind of day to day when you're completing your roles? So there's the scientists that you work with and that you are, but are there other healthcare professionals that you also work with regularly? Kind of open that up to anyone.
So sometimes we attend MDTs, so multidisciplinary team meetings with clinicians from other hospitals or and also we're part of a HODS service, so other genetic laboratory specialisms, so including like histology, immunophenotyping, and morphology. They will let us know like what they think based on testing the bone marrows, what disease type they think it is, and then that helps us with what genetic testing we need to carry out.
Fabulous, thank you.
Yeah, so in terms of our, at least mine and Claire's role, so we're involved in the diagnostic side, so very laboratory based. We're using automation and we're using our analysis techniques to try to understand variants and to interpret the results. It's then the clinicians, the kind of the doctors, to the ones which really have the kind of the deep-seated kind of understanding of some of these diseases. So as Claire says, we have regular meetings with those, especially to go through more complex cases where it's not a kind of an immediate kind of answer, because not all of these tests necessarily give a discrete definitive answer. So it's really important some of those kind of ones that are on the borderline as to what we're kind of looking at and understanding. And we also work with genetic counsellors, who'll be the individuals that typically are the ones which talk to the patient after a diagnosis has been made, especially with the more serious and severe disease. So yeah, you're completely right that we don't exist within a vacuum. And there's also the 7 genomic laboratory hubs across the country as well, who undertake some kind of core tests, but then there's also specialist tests, so we'll occasionally have to interact with those to route samples to appropriate places as well.
That's a great, thank you. I think what you said is really important about how every role plays a really important part. So you might do your part, but you need to work with other people to figure out what the issue is, and then someone needs to work with the patient to help them deal with that diagnosis. So it kind of shows how integrated all of these roles are. Are there other kind of professionals you work with within your role, Jodie?
Yeah. Likewise, we do work with people of other disciplines, kind of similar to Chris and Claire. Like, we also are in close contact with doctors. So doctors are kind of responsible for guiding us with our treatment planning. So they'll indicate to us sort of where they think the cancer is in the body, and then we plan to what they've guided us for. And likewise, when we're delivering radiation within a body, sometimes there's going to be some radiation delivered to bits that don't have cancer. So doctors kind of guide us on how much we can deliver to those structures. So yeah, no, we work quite closely with doctors, and also I know you've already mentioned therapy radiographers, but we work quite closely with them as well. So they'll be actually seeing the patient when they come for their radiotherapy, setting them up and delivering the treatment. So they're like a really important first line of defence in terms of safety as well, like if they've got any safety concerns, and then also things to do with like planned dosimetry, or yeah, just anything really they would need physics advice on. We're in contact with them when they're actually delivering treatment.
Thank you. I can see we've had some more questions from students as well. So attention to detail is obviously really important in the roles that you kind of do. And a student has asked here, what happens if mistakes are made in your job? So I guess attention to detail is really important, and mistakes do happen. So what kind of things are put in place if there are any mistakes that happen? Is that the reason why you might work as part of a team? So what happens if mistakes are made in your job, and also I guess what's put in place to prevent that from happening?
That's a big question for 9:30 in the morning. So embedded within all kind of labs or all kind of processes would be a quality team. So there'd be individuals and a kind of a section almost of laboratory who are responsible for the quality of the laboratory. So that covers a wide range of things, as well as ensuring procedures and kind of automation is kept documented and up to date and validated. And all of those documents are available for everybody. In terms of the kind of processing of the lab, and there's quality assurance and quality control. So quality control would involve things like running known material alongside unknown like patient samples to ensure that the correct results are obtained within the test. So if we have like negative and positive controls, that allows us to know that the test is working, and also information. And then we have quality assurance. So this could be things like external assessment schemes where samples are sent in to us where we're expected to return like a known result from an external regulator. And then in terms of the day to day, clearly like the process is the most important thing, and processes should be designed in order to minimize the potential for individual mistakes and errors, but inevitably they do happen. So there's an incident reporting systems that we have within the laboratory where those are all clearly documented, noted. And then there'll be immediate corrective actions that need to be taken or communicated externally if required. And then obviously looking to improve processes so that such incidents can't happen again. But it's not necessarily about it being somebody's fault. It's really about understanding what's happened so that we can all work together to make it better.
Yeah, and I think there you've just also highlighted even more roles that exist within the NHS in terms of people's job to monitor quality and safety and all those kinds of things. So that's also another part that sits within roles within the NHS as well. Thank you for answering that question. We also have another question here that says, how many healthcare teams are there in a hospital? So I suppose for you guys, how many kind of science teams might there be typically within a hospital? Is there a wide range? Is it just your team? How does it kind of look?
So I can kind of only speak for my hospital, my physics department really, but we have a whole range of physicists. So there's a quite a large radiotherapy physics team because we are a cancer specialist hospital, but we also have a team of MRI physicists who are helping with all the MR imaging processes. We also have a team of nuclear medicine physicists. So yeah, just kind of like another group of using sort of unsealed radioactive sources for imaging and treatment of cancer. And we also have a diagnostic radiology and radiation safety team. So yeah, they're involved in like imaging, so kind of like X-ray imaging, CT imaging, that kind of thing. And yeah, they also provide radiation safety support. So just making sure that we have all of the systems and engineering in place to minimise radiation dose, not only to staff but also to patients who are receiving treatment. So yeah, we have a whole range of different groups of medical physicists in our hospital.
Great, thank you. And how about yourself, Claire?
Yeah, so we have us as the genetics department, but there's also the 7 other genomics laboratory hubs around the country that will also communicate and, you know, may have to send off samples for that a specific laboratory hub does testing for. But then there's also me on the oncology department has to work with histology, immunophenotyping. So that's at Liverpool Clinical Laboratories, just over the road at the Royal. So that's highly connected to oncology in particular, because all of our results together will determine the diagnosis and therefore the treatment. And then I suppose we've also got the genetic counsellors that will then deliver information to patients. So what our results are can then be given to the patient. So I suppose, you know, we're just working with a diverse range of lots of people in lots of different jobs, and we all have to do everything together.
Thank you. And what you just mentioned there about the genetic counsellors, I think links to a question that a student has asked. So what happens if you diagnose someone with a condition, or the condition they've got they can't find a cure for a patient? So I suppose that might link to the role of the genetic counsellors and working with the patients for that. But I imagine that sadly can a lot of science means that you can tell people positive news, but then you can diagnose people and then there's not actually a cure beyond that. So what kind of happens in terms of a patient's journey once they receive that diagnosis and maybe there isn't a cure for what they've been diagnosed with?
A lot of people are diagnosed with a rare disease, and though there may not be a cure, it's often a help that people have a diagnosis and they know, you know, I have this. It's got, you know, I'm diagnosed with something. There may not be a cure, but it often helps people to just have a diagnosis. And often, especially on the oncology section, people do get bad news, but just having a diagnosis and determining what it is, there's lots of new therapies and treatments out there that can be trialed because they can take part in trials. So often it's just the diagnosis is often just a great help to people.
Yeah, there's also definitely in terms of we don't necessarily see this, but in terms of the genetic counsellors, they'd be the first port of call. And as Claire says, the diagnosis, which can sometimes go for years, with patients trying to understand, via various testing routes, what it is that is causing their symptoms. They've been able to provide that, and then that diagnostic odyssey is one part of it, as well as support networks are really good as well. So especially with the internet and community groups online, people being able to connect with other people across the world that maybe have similar symptoms and they're trying to manage conditions. But clearly the ideal aim is to provide a diagnosis which does have known treatments or symptoms. So being able to give personalized medicine, because some diseases may appear on the surface to be comparable and have similar symptoms, but there may be different genetic pathways which are causing those diseases. So as being able to not just necessarily provide that diagnosis, but to understand why it's happening, allows the clinicians down the line to provide different types of medicine treatments, especially these days, as we know, gene therapies and those really high precision treatments that can be used. So yeah, that's kind of the benefit of being able to provide that genetic answer.
Yeah, I think maybe from a radiotherapy perspective as well, we can provide palliative radiotherapy. So, trying to ease symptoms and improve quality of life for patients who, unfortunately, may not be cured of their primary disease. Something that I've been working on recently is trying to improve the way that we treat so patients who have their cancer has spread to the spine. We've been trying to have a look at that and see if we can change the way that we deliver radiotherapy to the spine in that instance, with the hope that the clinician that we're working with, the doctor, with the hope that sort of chemotherapy and other more aggressive treatments can be delayed, just to improve the quality of life for that patient group. So yeah, just trying to improve our treatments and optimize our treatments for that group.
That's great, thank you, all three of you. That really helped answer that question. I can see we've had one more question that we haven't answered yet in the chat box, which says, how do you keep up with the latest developments in your field? Which I think is a really good question, because science is always evolving and changing, and then you're always kind of thrown curveballs as well that you might not have been expecting, and new discoveries and things. So it'd be good to hear from all of you how, once you're in that field, how you keep up with the latest developments and evolve the methods you use and technology you use and things like that.
Sure. So Claire and I actually, so we're still technically pre-registration, so we're still trainees. I've only been in the role for 6 months, so we are actually at the moment both on kind of a continuous training kind of pathway. So we're constantly moving around different services, and that can take the form of training from registered clinical scientists and shadowing things in the laboratory, etc. In terms of the broader question, so within scientific roles, there's continued professional development, which is something that even when registered kind of staff or scientific staff need to ensure that they're maintaining that level of knowledge, as you say. So this can take the forms of attending conferences. So I attended the Festival of Genomics virtually at the start of the year, for example. It could be reading scientific papers that have come out. So typically laboratories or individuals have subscriptions to scientific journals. It can be watching webinars which are hosted by so industry partners, either new software, new instruments, etc. Or even kind of going to journal clubs. That's like a popular thing. We have a weekly educational session across the Northwest Genomic Laboratory Hub. We have like different cases that are presented or new projects that are being worked on. So it's a good question, and it's one that like it never stops. And again, going back to what I said about doing something that you enjoy, if that's fun, like I enjoy listening to science podcasts when I'm cooking my tea and stuff like that. So that's something which, if it's something that's enjoyable, it kind of comes naturally, and it's something that it's kind of above and beyond kind of need to do for your day-to-day role, but clearly the benefits manifest themselves.
Thank you. Did Claire or Jodie have anything else to add to that? That was quite a comprehensive answer.
No, I don't think so. Yeah, I think across all disciplines, like carrying on with professional development kind of takes like quite similar forms. So yeah, attending conferences, keeping up with publications, and yeah, we even have like local meetings as well of interesting cases that have come through, or clinical decisions that have been made for unusual cases that we like all learn from. So yeah, it's quite similar how we both would do that.
Fabulous, thank you. So are there any kind of, I don't think there are any other questions that I've missed in the chat. So I'll just quickly reshare my screen again. Thank you so much to our ambassadors for giving us all of that information. It was really, really useful. And if people do have kind of questions that they'd wish they'd asked, please get in contact with us at careers.hub@mft.nhs.uk, and we can try and answer any of those questions for you. As with all of our sessions, you have the pre-session task and the post-session task. And we wanted to, because this is all about science in the NHS, you've heard a lot about those healthcare science roles today, but we wanted you to explore other roles as well to do with science in the NHS. So for the post-session task, we would like people to watch this short video clip from Northwest Ambulance Service and then consider which aspect of STEM, so science, technology, engineering and maths, fits into the different roles that are discussed within this. So it can really get you thinking about what your interests are, maybe what options you're picking or what you're looking to do in the future, and how they fit into roles, particularly within the ambulance service. But you could also do this for lots of different roles within the NHS to see where your interests and skills lie. And like Chris said, if you manage to find a job that you really enjoy and that you're really interested in, it really helps in kind of enjoying that role and looking forward to going to work and completing that role. As I said before, if there are any questions, please get in touch with us at the Careers Hub. We also have kind of all of the social medias, and you can see other sessions that we are doing in the future and sign up to those as schools, classrooms or as individuals. So please keep an eye out for those and follow them if you want to as well. And I'll stop talking there and kind of hand back over to you.
Okay, brilliant. Thank you, Chloe, and thank you so much to all of our ambassadors as well. It was absolutely fantastic to learn about all your roles and your journeys and kind of how you use science every day into the NHS. So as Chloe said, everyone watching today, you should have already had the session card, so you can learn more about everything that our ambassadors have spoken about today. If you don't have this, please ask your teacher to share it as well. And for any teachers, parents and carers that are listening too, we've got a short feedback form that I will just pop into the chat as well. So please do fill this in, as we really want to make all of our Meet Your Future sessions kind of as interactive and as interesting and as pertinent for you as possible. So finally, thank you everyone for joining us today, and I hope you have a lovely rest of your week and of your Thursday. All right, thanks everyone. Bye.